My name is Steve. I write it as Steven. Spoken, it's Steve. That's difficult and annoying, and I'm sorry. On Twitter, you can find me. I'm at ppopowitz. That's Pepopowitz. The name is way more interesting than the story is. It's just a character from a TV show. That's it. If you want to get a hold of me by email, steven.j.hicks@gmail.com. And then all of the slides that we're going to go through here are available online at the URL that's at the bottom there, stevenhicks.me/getting unstuck. I will keep that URL up on the slides the whole time in case you want to write it down at any point. I'm just going to say thank you to the Dowdens for doing this. This is really cool. Thanks for having me. Very excited to be here, and thanks everybody for hanging out. And I guess what is the new normal, at least for a little bit, as we just kind of say hi from a distance. I'm an engineer at Artsy. Artsy is a company that's based in New York. I don't live in New York. I live in Milwaukee. I work remotely for them out of my basement here in Wauwatosa, which is, it's basically across the street from Milwaukee. It's the first suburb west. But Artsy's mission is to expand the art market. And we are doing that with a platform for collecting and discovering art. And I have a lot of really, really great coworkers. And they've helped me kind of realize that one of the things that I'm really, really interested and excited about is what it means when you get stuck and how do you get unstuck. And so I just want to really quickly define what I mean by stuck. It's a pretty nebulous word. What I'm talking about is when you've been looking at code for minutes or hours or days, and you keep looking at the same code over and over and over, and you just think, I don't know why this doesn't work. It should totally work, but it doesn't. Or you look at it and you think, I don't know why this does work. And for some reason it does. But you've been looking at it for so long that you were starting to get frustrated. My favorite thing about development is that act of getting unstuck or helping someone else get unstuck. So if I hear in stand-up that somebody is stuck on a problem, my ears perk up and I just get excited and I'm like, this is my time right now. So over the past few months, like I said, my coworkers are really great, and I've taken notes about how I and my coworkers help each other get ourselves unstuck. And so really this talk is just a collection of all the things that we've talked about and a little bit of deeper research into why some of these things work. And so the first strategy that I have to offer you is not so much a strategy about getting unstuck. It's more of a mindset shift. Embrace the act of getting stuck. And so this is a point where I usually do a survey in a room, but we don't have a room. What I'm going to ask is for people to use the chat box here within our meetup. And I want you to answer two questions. You can answer them in the same line. But the two questions I want you to answer are, what's your experience level? Do you think of yourself as a junior level, mid-level, or senior? And then the second question is, have you gotten stuck on a problem recently? So for example, my answer would be senior and yes. And I'm just going to let some of these answers pop in. I know we don't have a whole lot of people here, but I'm going to wait for at least a few answers to show up. Absolutely. I like that one. Okay. The silence gets awkward. We'll move on. What you would typically see in a room full of people, and here actually this is demonstrating it perfectly now, beautifully now. Everybody answers yes. It does not matter whether you are junior, whether you are mid-level, whether you're a senior. Everybody gets stuck as a developer. I have a coworker named Will, and he wrote an article about meditation. It's called "To Start Meditating, Stop Trying to Empty Your Mind." And he talks about how in the act of meditation, or the practice of meditation, a lot of newcomers think that they're bad at it because they can't empty their mind. Their mind isn't empty. They're always thinking about things. Their mind is wandering. Will makes the point in this article that that having an empty mind is not actually what meditation is about, especially as a beginner. Meditation is more about mindfulness, and it's about noticing that your mind is wandering and recognizing that your mind has drifted, greeting that thought, and then letting it go and returning back to your focus. And that's it. He says, it may feel frustrating and like you're doing it wrong, but that is the practice. And I think this is really similar to software development, because getting stuck is, in my opinion, not a reflection of your skill level or your experience level. As we saw in the chat window, everyone, whether they're junior, mid, senior level, everyone gets stuck. It's also not an impediment that prevents you from doing your job. It's not like you start your day as a developer and everything's going great, and then you get stuck and your day is ruined. Because really, getting stuck is the job. And that's why we get paid to do this job. That's what makes us different from other people. It's a unique skill that we have. We have the ability to get stuck on a problem, bang on it 100 different ways, and then get ourselves unstuck. Your job and my job is to solve problems. So it's okay to be stuck. That's just you doing your job. It's not about writing lines of code. It's about solving problems. And solving problems takes a lot of time. So it's okay if it takes you a while to get there. So that's my first set of strategies. My second set of strategies are around explaining the problem. When you've reached that point of being stuck, go ahead and write about the problem to someone. You could send someone an email. You could send them a Slack message. Sometimes I like to type a message up to the Slack bot. So there's actually no person that's going to receive it. I'm just typing it into the Slack bot. You could visit Stack Overflow, or maybe you're the kind of person who likes to blog about things, and so you could just start writing up a blog post. You may never ever finish it. You may never publish it. GitHub issues are a great thing to write up. And like I said, I really enjoy writing those messages to Slackbot. Because really, you might not even have to send the message. A lot of times, we figure them out before we even finish writing them. If you're more of a verbal person than a written person, and this gets a little bit harder now that we're not all in a shared space together, but we can still reach out to each other for a call when you get stuck on something. Talk to the duck. This is talking to the duck is something that comes from, I think, The Pragmatic Programmer, a book named that. And the idea is basically just that you have some sort of little rubber duck on your desk. And when you get stuck on a problem, you just start verbally explaining things to the duck. It doesn't have to be a real thing. It can be a real thing. It can be totally imaginary. You could just imagine that there is a superhero sitting right there on the side of your desk. But it's definitely most effective when you talk to the duck out loud. You have to explain the problem to the duck. If you do it in your head, it's not going to be as effective. But walk the duck or the robot or the superhero through the problem. Explain to them what's working that shouldn't be or what's not working that should be. And the duck can be a fake thing, but it can also be a real thing. If you feel like talking to the duck doesn't get you anywhere, go ahead and this is the point where you reach out to a coworker and say, hey, I just need 5 minutes of your time. Can we start up a call and I can explain this problem to you? This is really the same thing as talking to the duck, except that the duck is now your coworker. But ask them to just kind of look over the code with you, explain to them why you think the code is right or why you think the code is wrong. And they may see something, or maybe they'll ask you some questions that really trigger some thoughts that help you figure out what's going on. Taking the talk to a person step a little further, you can pair with them. We pair a good amount at Artsy. The team that I'm on, we're definitely interested in pairing. There have been days where we don't do an entire day. I know there are some people who will pair an entire day, but there are days where I feel like I could do 4 hours straight with one of my teammates, and we just all of a sudden it'll be the end of the day and we won't even realize it. But a couple hours a day is really, really great. Or even in the case of being stuck, just 15 minutes where you take turns typing. And using one of my favorite tools for this would be Visual Studio Live Share. It's a really great way for you to both be able to type and enter code in the same place. And maybe as a pairing exercise, you want to take turns typing and have one person drive the other. But regardless, it's a great way when you're stuck on a problem to think about new ideas or get a new perspective on what you're looking at. So these explain strategies work for a couple of reasons. Partially, they can be explained by something in psychology called the protege effect. And the protege effect is something that you've experienced if you've ever taught someone something. Maybe you've taught someone through a one-on-one or through a lunch and learn or a workshop, or you've taught newer employees at work. If you've done any of that, you've seen this. What you found is that when you teach something to someone, it makes it so that you understand it better than if you hadn't taught it in the first place. It really settles into your brain a little bit deeper. And there's a couple reasons that are happening. For starters, because you're going to have to explain it to someone and you don't want to look like a fool, you are inspired to learn the topic thoroughly so that you can teach someone else. So you actually use better learning strategies to learn the material that you're working through. It also inspires you to do what psychologists call metacognitive processing, and that's thinking about how you would actually go and learn the project or learn the topic. While you're learning something, you're thinking about how you're learning and how you might explain it to someone else. And there have been some studies, a small number of studies that have been done about the protege effect. I'm going to highlight one from 2016. In this study, the control group was told, here are some things that we want you to learn. Go learn them. And then the experiment group was told, we want you to learn these things, and then we want you to teach them to someone else. And what the researchers found in this study was that the students in the learning by preparing to teach intervention developed a more detailed and better organized concept map of the problem. And I'm going to zoom in a little bit on that quote to a specific fragment of a sentence. Learning by preparing to teach. That's how they referred to the experiment group. Because the truth is, in that study, that group never actually had to teach anyone. They were just prepared that they were going to teach. And so this is where we think that they started choosing better learning strategies to get the material more deeply into their brain so they could explain it. Another thing that happens when you're explaining is that it'll force you to challenge your assumptions. You have to prove that the code that you think is running is actually running. In my opinion, this is one of the most critical and important things about all these explanation strategies is that they prompt you to challenge these assumptions. And it makes me think of some other things that I've experienced. One is comes from a psychologist named Mihai Csikszentmihalyi, who wrote a book named Creativity, subtitle Flow in the Psychology of Discovery and Intervention. If you're not familiar with him, you are likely familiar with this work. This is where he introduces the concept of flow, where he talks about how you can get into that state while you're working, where all of a sudden hours go by and you don't even know what happened. You were just working on that exact right level of difficulty of problem, and all of a sudden you time traveled to the end of the day. But in this book, he talks about other things, and he says one quote that I really, really like: experience this one thing for what it is, not what you think it is, which I think is really good, a representation of challenging assumptions. And it actually reminds me of when I was in high school art class. I remember being told many times by my art teachers to draw what you see, not what you think you see. You think about it when you sit down and draw something. You're not necessarily drawing what your eye sees, you're drawing what your mind sees. And so when you see this drawing, you recognize it instantly as a drawing of an eye. I do too. It's got that eye shape, and it's got an iris, and it's got a pupil. But that's not really what the eye looks like at all. This is just a symbol of the eye. In reality, the eye has much more detail and subtlety. It's not a symbol. It's not a heuristic. It's not a shortcut to what the eye looks like. It has a ton of different colors in the iris. Now, these are blue eyes, but there's blue in there and green and brown and gray. You can see the reflection of the eyelashes in the eyeball. There's the bloody, fleshy thing in the corner. And the way this relates back to code is if you think about your code, when you're focused on a problem, you use symbols to describe it. So maybe I have this system of code in my head that I'm working on. And there's 4 different things that are involved. 4 different colored blocks here. And I built up this model of how all these pieces work together. But I have to treat them in my head as black boxes. They become symbols of, oh, that's just the database. Or, oh, that's just the settings helper file. That's where things happen. They're symbols, and you just assume that they all work as intended. But behind each one of the black boxes lies a ton of complexity and a ton of detail. We have to treat them as black boxes, though, because if we don't, we become overwhelmed by all the complexity and all the detail. We can't possibly understand the system because there's just too much going on. But in reality, our black boxes never work as we intend them to work. And so these strategies of explaining the problem, they force you to evaluate every single assumption and every black box and explore the details of each of them. And that's often what helps you uncover the issue. Strategy group number 2 is about isolation. We're going to find ways to isolate the problem so that we're solving a smaller problem. And we'll start with some risk analysis. We're going to ask ourselves some questions. What is the thing that I've introduced to my code that I know the least about? This could be a dependency or some new code that you've just written. What is the thing that is most likely for me to improperly use? Again, it could be a dependency, it could be some existing code that you just aren't totally sure how to use properly. And what is the thing that I'm making the most assumptions about? And if you can give a solid answer to any one of these questions, there's a good chance that that is where you're getting stuck. That's where your problem lies. Whether you can give a solid answer or not, we can start with some more isolation strategies. We can start removing code. This will help us isolate the source. And so if we think about our code as a set of blocks here, where I've got some things that are happening, let's just do a binary search to find the exact code that isn't doing what it's supposed to do. So maybe we pull out that bottom box and say, okay, let's just run the top half. And in the bottom, we'll run one line to just replace it. And maybe the problem is still happening, and so you're not totally sure. But now you can iterate and repeat the process of just eliminating code that may or may not work, and based on that elimination, deciding if you just removed the code that was broken or the code that is broken is still there. So instead of dealing with 50 lines of code that don't work, you now have 10. We can also do a binary search of your recent changes. So if your code is if you're using something like Git to keep history of all of the changes that you make, then your code base is it's basically a timeline of commits. And assuming everything worked before you started making changes, you can go ahead and you can just start rolling back each one of those changes. Reverse the last commit, pull it off, and see if your problem still happens. And if the problem is still happening, go ahead and pull that other most recent one off. And again, now you're narrowing it down from 50 lines of changes to 10 lines of changes. And this is actually such a great strategy that it is built into Git. And if you use Git, there's a command named bisect, which I didn't know existed until I originally wrote this talk. But the way Git bisect works is you tell Git, here's my last known good commit. Here's my my first known bad commit, find somewhere in between where things actually went from good to bad. And it'll check out commits for you in between the good and the bad, and use a binary search to help you identify where the commit broke. You just have to check along the way, is it broken or is it fixed now? If you think of your system of code as this super sweet Lego camper that my kids built, and something in this system is not working right, the code removal strategies that we just talked about, they're kind of like taking that and just deconstructing it, taking it apart. We're pulling sections of the camper off until we find out that we used the wrong piece. But sometimes it's different. And sometimes we're not even sure we can build the camper to start, because we don't know if the pieces are going to fit together. We don't know how they're going to fit together. We don't know if the wheel is going to work with the windshield or if the windshield is going to work well with the raft. And in these cases, it's useful to isolate your problem by building a proof of concept. So let's start building a very, very small demonstration of our system or our problem, and see if the pieces will play nicely together. Because sometimes they don't. And sometimes that's the source of your bug or your issue, or why you're stuck, because it turns out that you couldn't actually use this library with this other library. There's another subcategory of being stuck where you don't even know where to start. You're just stuck in the state of analysis paralysis. And in that case, and also in the case of building a prototype, my recommendation is to eat the frog. And eating the frog is an idea that comes from a famous Mark Twain quote. The internet says it's from Mark Twain. I don't think anyone can prove that it's from him, or maybe they can. I don't know. But he says, eat a live frog first thing in the morning, and nothing worse will happen to you the rest of the day. I don't know if anyone can confirm that, but it seems sound to me. But the idea with eating the frog is, say I've got my system of code again, and I've got all these 4 different pieces that work together, and I have to build this thing, and I don't know where to start with it. I don't know how to even begin. I just know I have 4 pieces. Maybe the top left is the UI, and the top right is a Rails app, and the bottom left is like an Elasticsearch index, and the bottom right is a Mongo database, and you're just scared. You don't know how to move forward with this. In terms of eating the frog, the way I would approach this is, well, let's actually take a look. Let's look at each one of these pieces of the system. Are all 4 of them scary, or is just one of them scary? Chances are, some of the problems that you're dealing with, you've already dealt with in the past. But there's probably one thing in there that is just really, really intimidating you, and you're not sure how to move forward with it. In that case, I think it's best to take that one that is the scariest and start there. Start with that one. Don't put it off and try to get the other 3 playing nicely together, because you probably know that those will work fine. Start with the scariest one, and this will give you information about how the system is eventually going to come together. And if the hardest problem does seem like it's too big, go ahead and see if you can break it down further. Try to identify multiple problems inside of it and separate them and approach them one at a time. Again, starting with the scariest. Another way to isolate a problem in your code is to write tests. I like testing because I think it's a really good way to tighten your development feedback loop. That loop where you make changes, you observe the effects, and then you repeat the cycle. And there's a few ways that I've used tests, automated tests, to help me isolate issues before. If you think of your system as a tree of functions calling each other, we can take each one of those functions and write unit tests of each one of them and make sure that each one is doing what we think it is. And if we go through that process and we find that the majority of them are, but hey, this 4th one is actually really, really hard to get this test to pass, this can help you verify if this specific function is a problem or a different function is a problem. And the ones that you tend to have problems with are generally where your source of stuck is. We can also, given a large untested piece of existing code, write tests of that code. And it's hard to write tests to cover existing code where there aren't already tests. But one really nice strategy for doing this with existing code is to actually find pieces that look like they could be isolated and extract them into their own function. And then go ahead and test that function. And if we find that that function, when we extracted it, is doing everything that we thought it would do, we've just learned that that's not where our problem is. And so now we can focus on the rest of the code to try to find the problem there. And then a third type of testing for helping you isolate problems would be integration tests. If we again think of our broken feature as this subtree of function calls, we can write an integration test that tests the entire subtree. So maybe it's like an entire page of your app. Write an integration test of it. And it should fail because we're having problems. And so we shouldn't be able to get the test to pass as we would think it could. But once we're there, let's go ahead and just actually choose a sub-branch and write a test one level down from there. And if we find that this branch is hard to get passing, then we're on the right track. We know that this is where we're going to find our issue. And so we can, again, arbitrarily choose a branch below it, and we can write tests of those branches. And we'll see one where the tests pass, and now we'll know, okay, we don't need to worry about that. That code works fine. These, where we can't get these tests to pass, let's keep traveling down that subtree. The isolation strategies, the common thread for these is that you're breaking problems down from something large to something small. Because if a problem has a smaller surface area, it's going to be easier to figure out. Next set of strategies is about escape. And this is my personal favorite set of strategies. Get away from the problem. Just walk away from it. Relax. Go take a shower or take a nap. This used to, when I would give this talk in person, that would be a funny joke for people who weren't remote. They'd be like, I don't get to just take a shower in the middle of the day. That's not a thing that happens. But now that everyone's remote, maybe you have that opportunity. When you relax and you shut your brain off from a problem and you let your mind wander, there's other areas of your brain that get a chance to activate, and they can find solutions without you trying anymore. You also become more open-minded to the problem. You become less likely to dismiss ideas that don't seem obviously related. My personal favorite approach when I'm looking to escape a problem is to get some exercise. Physical exercise increases the blood flow to your brain, and it helps improve your executive functions. It improves your mood, which is important because having a better mood can give you that push that you need to get back to the problem. And I especially like physical exercise when it's something that is rhythmic and repetitive, like running is really important to me. But when it does become rhythmic and repetitive, your mind can just shut off and it doesn't have to think about the running anymore. It can wander wherever it wants. Or other hobbies. Maybe you like to play guitar. Maybe you like to draw. This is a similar effect to resting. Your brain explores new ideas. And if that feels like it's too much procrastination, take the problem you're working on and set it aside. And work on a different problem that you know how to solve, or that is going to be easier for you to solve. This feels like you're not escaping because you're being productive and you're working on other problems. But it has that similar effect of you're no longer actively focused on the problem that you're stuck on. Why do these escape strategies work? There's three things that are happening. I mentioned this earlier. Escaping can boost your confidence. Solving a simpler problem can give you the confidence that you need to go back and smash the original problem. I like to do this in rock climbing. Well, I liked to do this when I could go to the rock climbing gym. But in the rock climbing gym, I'd often work on a climbing route that I would just get stuck on, and I couldn't get past a specific spot, and I'd get frustrated. But then I'd just look around the gym and look for a couple really, really easy, simple climbs that I knew that I could do and just go knock those out. And then that gave me back the confidence that I needed to get back to the difficult problem. Another thing that happens when you escape is that when you come back to the original problem, you have to relearn it. And this can help you challenge assumptions, kind of like talking to the duck. All those things that you weren't thinking about before when you were living in the problem, you have to kind of refresh your memory about, oh, how does this thing work again? And the third, and in my opinion, more interesting thing that's happening is that your brain can actually come up with the answer on its own while you're thinking about other things consciously. And there's a couple of psychological principles involved in this. The first is called analogical problem solving. And this is when we use information from one domain to help us solve a problem in another domain. So this happens when you notice parallels between two really, really different activities. Maybe you're running and then something happens and you think about how that duck just ran across your path, and suddenly you start thinking back to the problem that you were having. And now that you've noticed one parallel between these two very different activities, now your mind starts reframing the problem in a way that you hadn't thought of it before. And another thing that happens when we're escaping is called incubation. And incubation is a stage of creativity. The stages of creativity were originally described by a political scientist named Graham Wallas. And Graham Wallas in 1926 described these stages that we go through when we're being creative. The first one is preparation. We investigate the problem consciously in many different directions. So we're actively working on this problem. Step 2 is called incubation. And in incubation, you actually put the original problem away. You don't work on it. You do nothing, or you work on a different problem. And at this stage, your subconscious starts to process it without you having to do it consciously. In stage 3, the preparation and the incubation come together, and you're illuminated with a sudden insight. This is the light bulb that happens while you're in the shower and you suddenly remember or figure out why you were stuck. And then in stage 4, we do some verification. We do conscious analysis of the idea, and we just prove it out to ourselves that this is a thing that we think will actually work. Graham Wallas was very clear that these don't happen in isolation. They very much play together. And it is not sequential necessarily. More recently, someone we mentioned earlier, Csikszentmihalyi, the psychologist who wrote about flow, took those 4 stages and turned them into 5. And he said, okay, instead of that 4th stage, 1 through 3 are going to be the same. Instead of the 4th stage, I'm going to break it into 2 things. Evaluation, where we're going to vet the idea and see if it has legs. And then elaboration, where we're going to expand on the new idea. Test them, refine them, figure out how we can apply them. But I especially like Mihai's version because he also describes incubation really, really well. He says, in incubation, ideas churn around below the threshold of consciousness. It is during this time that unusual connections are likely to be made. When we intend to solve a problem consciously, we process information in a linear, logical fashion. But when ideas call to each other on their own, without our leading them down a straight and narrow path, unexpected combinations may come into being. My emphasis was on unusual and unexpected. And he actually goes to describe this to parallel computing, right in our wheelhouse. He says that when we're consciously thinking about a problem, we're pushing our thoughts in a linear direction. But when we set it aside and we let it incubate, those thoughts, they become parallel. And now there's a freedom to your problem solving, and things can combine themselves in ways that your conscious mind would have rejected as being, no, that's silly. So go ahead and set it aside. When you're faced with a difficult problem, you often think, I really need to focus on it to figure this out. The truth is, while we think that we're procrastinating by not actively attacking it, for really complicated problems, we're helping the situation, where our brain and our creativity need to expand in many directions to find a solution. And staying actively focused can be a detriment in this situation. So if you give your brain some room to explore the space on its own time, it can help you explore ideas that you previously would have just dismissed. So go for a walk or work out or take a shower, take a nap, read a book about something unrelated, get in your basement and do some woodworking, knit. All these things are great. My favorites, mountain biking, trail running, rock climbing. Just let your brain expand this problem in as many different directions as possible. And so now let's move on to the set of strategies where we figure out how to harden ourselves for the next time. Because like we said at the beginning, getting stuck is the job. So we know it's going to happen again. You can learn new ways to solve problems. You could go read some code on GitHub, code that's in other projects. See how other people are solving problems in their code. You can explore new technologies. You can learn for the sake of learning. Pairing is a really, really interesting way to learn new ways to solve problems, because you'll see the ways that another person would approach a very, very simple problem that you never would have thought of. I keep a Trello board that I fill with messages of appreciation and thanks and things that feel like really big accomplishments to me. And I go back and I look at it now and then. And I call it my wall of motivation. When I get stuck, my self-talk changes and I start saying negative things about myself. I start doubting myself. I start saying awful things. The imposter syndrome that I feel often, it really kicks in when I'm stuck on a problem. But going back to review something like a wall of motivation, it'll replenish your ego and help you get back at your job. And it'll remind you that you are, in fact, doing a great job, which is an especially important thing to remember right now, as if you're like me, you just have a hard time focusing, thinking about the work instead of what's going on around you. Keep a journal of everything that you do throughout the day so you can see that you are getting things done. Sometimes they're not things that you can immediately check off a list. Maybe it's not the exact things you wanted to accomplish today, but you worked on things. You maybe spent 2 hours trying to figure out this one problem. Maybe you didn't get to the solution, but you definitely were doing your job, which was to try to figure out how to solve that problem. Again, get some exercise. It can reduce anxiety and depression. I especially like rock climbing because it hardens your problem-solving skills and your persistence. Now I'm focused more on running because it's a thing that I can actually do. And meditation has a lot of mental and physical benefits, especially leveling your emotions, which emotions factor into getting stuck because it makes you feel like you're not doing a good job. And meditation can also increase your ability to persist through challenges. Get outside of your head. Do more active one-on-ones with your leader or with someone else that you feel psychologically safe around, a friend, a coworker, someone that you can be vulnerable with and say, I've been stuck on this problem and I don't know what to do, and it makes me feel like I'm not good at my job. Talk about the times that you felt stuck, and they'll tell you about times that they felt stuck. The common thread for the hardening strategies is to condition yourself and get in the reps. Just like a professional athlete would condition themselves to overcome incredible physical challenges every day, professional developers can condition themselves to overcome incredible mental challenges. In summary, These are the strategies we talked about. We talked about embracing this act of getting stuck and getting unstuck. That's what the job is. That's what being a developer is. We talked about explaining the problem that we're having so that we can challenge our assumptions and try to figure out why we're stuck that way. We talked about isolation and taking bigger problems and breaking them down into smaller problems. Escaping the problem, walking away from it, setting it aside, and letting your subconscious process the problem rather than your conscious mind. And then we talked about some ways to condition yourself and harden yourself for the next time, because you're going to get stuck again, and that's okay. Thank you for your time, and we can definitely talk about questions.